Hello, welcome back to Networking Basics mini lecture series. In this mini lecture, we will talk about IPv4 address inversion. We will examine the various ways we can manipulate an IPv4 address. The topics will cover 32-bit IPv4 binary to dotted decimal, and vice versa. We'll also quickly look at determining how many bits for network ID and how many bits for host ID based on the prefix length and a subnet mask. Do not proceed with this mini lecture unless you have mastered the art of converting binary to decimal and vice versa. What is a dotted decimal address? A dotted decimal address, as the name implies, has dots, and the dots separate decimals. A dotted decimal address looks like this: 192.168.2.100. A dotted decimal address is for human consumption only. It is much easier to remember a dotted decimal address than it is to remember its 32-bit equivalent. Computers understand zeros and ones. Computers do not understand dotted decimal addresses. When you enter an address through an interface on a computer, you may enter a dotted decimal address, but that address is not stored in that format. It is converted by the computer into zeros and ones, into its equivalent 32-bit address. Let us look at how we convert a 32-bit binary to dotted decimal notation. First, we begin with our 32-bit binary and divide into 4 groups of 8. So we divide our 32-bit into 4 octets. We then take each octet and convert it to its decimal equivalent, and then separate the decimals with dots, and we end up with the dotted decimal representation of a 32-bit address. It's that simple. Now let us look at the reverse process. How do we convert a dotted decimal to its binary equivalent? Well, each decimal will convert to an octet. So we convert the decimal to its binary equivalent. We end up with 4 octets. We concatenate all 4 octets, and the result is our 32-bit binary address. Voila, it's that simple. Now let us look at something that may be a little more complicated. The question is, how many networks and host bits for a 32-bit address? From the prefix length and the subnet mask, we can determine the number of bits used for the network and the number of bits allocated to the host ID. So if we have a /24 prefix, then what the /24 tells us is the first 24 bits, the first 24 bits, or the high order bits of our 32-bit address represent the network ID. Now, we know we have 32 bits. If we've used 24 for the network, how many bits do we have left? Well, we have 32 minus 24 gives us 8 bits. So we have 8 bits left for the host ID. Remember that within the same network, all hosts within the same network will have the same network ID. The only portion that will change, the portion that is unique, will be the host ID. And in this case, it is worth re-mentioning that the 24 bits are the high order bits. So starting with most significant bit, we count 24 bits. And what is left will be in the low order bits. And in this case, we'd be left with 8 bits for the host ID. At this stage, I believe you are ready to practice on Blackboard. There are many practice tests to allow you to convert from binary to decimal, that is IPv4 addresses, and also from dotted decimal to 32-bit binary. I encourage you to try to do these exercises or practice tests as often as you can, where you should only stop and move forward only at the time or moment where you have managed to convert successfully at least 4 times in a row. Our next topic will be types of addresses in an IPv4 network. Thank you, and look forward to seeing you soon.